Hello, we're still in chapter 4, and our section that we intend to explain today is entitled Parallel and Perpendicular Lines. How, if we have the equation of two lines, how to know and how to verify that these two lines are parallel or perpendicular to each other. First of all, we should know the lines are parallel when their gradients are equal. And we say that these lines are perpendicular if the product of their slopes or gradients equal to -1. Okay, we can easily explain more for this relation of perpendicular lines. So what we mean that two gradients, two numbers, the product of two numbers equal to -1. Normally, the product of two numbers equal to -1, so equal to -1. First of all, to obtain a 1, so normally we are multiplying two inverse coefficients or constants. So a 1 over a. If we multiply it, we'll obtain a 1. To obtain -1, we should have opposite sign. If a is positive, so we have a -1 over a here. So plus a, -1 over a. So normally inverse and opposite in the same time. So easy. We will complete to find out how we will explain clearly the ideas of parallelism and perpendicular lines. Okay? In the first equation, in the first exercise, investigation, if we have two equations. First of all, we search for the x terms. Here it is. The x terms are 3x and the 3x. When we have the same coefficients for these terms, 3 are equal, so we are talking about parallel lines. So D, we have a 4x, we have a -3x. No, we don't have the same coefficient. We have here 4 as a gradient, we have a -3 as a gradient different. So we are not talking about parallel lines here. We have a 4x, we have a 3x. Regardless the equation or the form of the equation, here the equations are given as in the general form, and in the both first examples, we have the form y equal to mx plus b. Regardless the form, we search for the, for example, for the x term. In the general form, we search for the x terms and the y terms. Okay? We should have, if they are in the both and the same side, x terms, y terms, the same side of the equal, we should have the x terms and the y terms equal to obtain the same gradients. We have a 4x, 3x, so are different from the first step, from the first comparison of the x term, we have a difference, so not parallel. We have a 2x normally from the same side, so parallel. We have a 2x and we have a 2x. So how to proceed in this way? So first of all, we have a 2x and the 1. And we have a 2x and a -1. We should know that y is in one side of the equal and 2x in the other side of the equal. Or we can rewrite the general form in the form y equal to mx in order to deduce correctly the statement. Okay. So first of all, we put both equations in the form y equal to mx plus b is the easier step. So normally y equal to mx plus b. So we rewrite the general form equation of this equation in the form y equal to mx plus b. So 2x plus 4 equal to y. So y equal to mx plus b. M is 2 and here is 2. So normally parallel lines. Okay. Also, we can rewrite them, or we can investigate or deduce when the x term, the y term are both in the same side of the equal. 2 equal to 2, plus 3 equal to plus 3. So normally when comparing the coefficients of x term, y terms are congruent. So normally we are talking about parallelism. Okay, 5x, 3x, different, not parallel. And also we can write like 2y equal to x plus 3, then y equal to 1 over 2x plus 3 over 2. The gradient here is the half, different from -1, so not parallel, and so on. So it is very easy to deduce if we are talking about if the statement is representing parallel lines or not. Okay, so in the second exercise, complete to find the equation of the line parallel to y equal to 3x minus 5 and passing through the point -5 over 3. First of all, we should know that to construct, to build an equation of a line, we should have we should be on different statement. The first one, we could have, for example, 2 points. We search for from these 2 points the gradient, then we substitute the coordinates of one of these points to obtain the equation of a line. Or in another statement, we can have the slope and 1 point is sufficient to obtain the equation of a line. The third statement is to have, for example, parallelism or perpendicular statement and 1 point. Why? Because we are searching for the equation of a line parallel to this line. Parallel to this line, what we mean, two lines are parallel. They having the same gradients, the same slope. So first of all, we deduce that the equation is of the form y equal to 3x plus b. Okay, it remains that so that y-intercept small b remains to be find. Okay, how to find small b? We substitute the coordinate of this point, okay, that lies in the line that we are searching for. So normally we substitute y by 3 and the small x by -4 because we know that the first number here is for x and the second one in this couple is for y. And then we will obtain a linear equation with one unknown small b plus b remains, and we keep it in this side and we move -12 the other side, or we can say easily we add 12 to both sides to obtain small b equal to 15. Then the equation be y equal to 3x plus 15. So the main idea here that we should keep in mind that parallel lines have equal gradients and define the gradient by inspection or calculation. Easy, easy, easy. So in the same way, in the exercise 3, we have the same idea. We have a line. We want to find the parallel line to it, passing through another point. So I took this statement. So first of all, the line that we are searching for is with a gradient equal to -7. So we have y equal to -7 x plus a small b. So how to obtain the equation of the line passing through -5, -2? we can adopt the same idea that we did before here. We substitute y by to obtain the small b. We substitute small y by -2 and small x by -5. Or we can use the another y, the another inspection, y minus y equal to m minus 7. We mean -7, the gradient factor, x minus x. I put these parentheses because the ordinate also is a -1. Minus with minus will obtain a plus, and we complete our calculation to obtain y equal to -7x minus 37. Okay. What about perpendicular lines? What we mean by perpendicular lines? Normally, first of all, this equation, if we complete our work, complete to determine if the line y equal to -2x plus 5 is perpendicular to x minus 2y minus 4 equal to 0. First of all, we should find the gradient of this one and the gradient of this one, and we should verify if the product of two gradients equal to -1. So first of all, the gradient of this one is -2, but the gradient of this one is not clear for us because we should first of all put this equation, the form y equal to mx plus b. So to put it in the form y equal to mx plus b, we can first of all move -2y to obtain x minus 4 equal to 2y. So in this way, 2y equal to x minus 4. Okay, we divide by 2 all the terms of the equation to obtain y equal to 1 over 2x, okay, minus 4. So the gradient minus 4 over 2 minus 2. So the gradient is equal to 1 over 2. So if we multiply -2 by 1 over 2, we'll obtain -1, so we can deduce that the lines are perpendicular. What we can conclude from these numbers? 2, 1 over 2. The inverse of 2 is 1 over 2, invertible, okay? And this is negative, and the other is positive. Okay, easy, easy. First of all, the first statement, the first example is for parallel lines. The second one, invert. The numerator is in the numerator and the denominator is in the numerator. Good, positive, negative, so perpendicular, because if we multiply these two gradients, we'll obtain -1. Also, if we investigate this statement, so 1 over 3 is the inverse of 3. Cool. And negative and positive, so perpendicular lines. Okay, we can rewrite it, and for example, we can rewrite it in the form y equal to mx plus b to obtain y equal to 3 over 4x, okay, plus and here we will obtain y equal to -4 over 3x, Okay, so normally we have the inverse and the opposite. So if we multiply these gradients, we'll obtain -1. We can easily, the slope small m from y equal to mx plus b is equivalent to -a over b. We can easily deduce from the general form the slope -a over b. So we say -3 over -4 to obtain 3 over 4 as a gradient for the first equation. And this straight line is given by the general form, also 4x ax plus by plus c equal to 0. So the gradient, the second gradient, m2, is given -a over b, -a over b, so -4 over 3. If we multiply this gradient by this gradient, we'll obtain -1. So the slopes of two perpendicular lines are of opposite signs. Okay? So find the gradient of the line perpendicular to the given lines. So it is easy. -4 over 5. We can follow these steps, or we can say easily that the inverse 5 over 4 and the opposite, because this one is negative, so normally the other gradient is positive, +5 over 4. Okay, so it is easy. And also in the final part exercise, it's easy to follow the same strategy as we did before. So these are the main ideas, the parallelism and the perpendicular lines, and how to verify and to find the equation of a perpendicular line to another line, and the equation of the equation of a line parallel to another line passing through a particular point. Thank you for listening and have a nice day.